Alright, we're doing the standard deviation method. So we're testing, still working with these distances and angles of elevation for the home run data set. 28 degrees is the average, and like 396 feet is the average distance. There's a lot of home runs. This is 2017. We can find the length of those arrays. It's a pretty big number. So standard deviation, got an idea of what it is. We're getting a typical distance from that, from the mean. Okay, so I'll do public float getSD float data. Alright, and so first what I'm going to do is make a call to get average. I gotta spell it right. Okay, and there's nothing to do with the fact that these two parameters are spelled the same. It's passing this data to become this data. It's just named the same, but I'll change it. I'll do D here. Okay, so that's the average. My array is called D. All right. Now, basically, what I'm going to do is, I'll take a float sum. I'm going to add up the squared differences from the mean. Add up the squared differences from the mean. So we'll have, I'll run a for loop from 0 to d dot length, or strictly less than d dot length. Okay, and then I will add to the sum a squared variance. Excuse me, a squared difference. Okay, so a square difference is just how far each value is from the mean, and then I'm going to square that. Now, one easy way to square values is to multiply it by itself, or you can use POW. Okay, doesn't matter which one we do here. I'll use POW. So POW, this is going to square it. All right, the value that I'm squaring is D bracket I, which is the datum, individual data number. Okay, and then I'm going to subtract that from mean, which I just calculated here. Okay, so that is a difference, or what we call a deviation. Here I'm raising it to the second power. Okay, so it's each difference squared, and then I'm going to take the sum of that. Okay, so at the end of the for loop, I have the sum of the squared differences. I'll do a couple things to it. First, I'm going to divide sum by d dot length. Okay, what does that do? That gives me the average. Okay, because I added them up, and then I need to divide by how many there are to get the average. So that is the average squared difference. And then I'm going to return the square root of the sum. So that last statement is kind of undoing the squaring of these, which I tried to explain there in the reading for the standard deviation. But this should give us, that undoes the square root, squaring. By doing square root, we should have a getSD. So let me do, I'm going to take this one out. Distances is probably easier to comprehend. Paren ln getSD distances. So we know on average the average home run hit in 2017 was 396 feet. And this tells us that a standard deviation was 24 feet. Right, so one thing we can do is analyze, how well these standard deviation distances meet standard or normal distribution. If that were the case, then somebody who hit a home run like 400 feet, it'd be like 4 standard deviations above the mean there. And 300 feet would also be like 4 standard deviations below the mean. So that gives us an idea, and it may not fit a normal distribution, but we can take a look at it.